day. Today, we are going to discuss the sample size determination. So, what would be the number n or the number of sample size that we are going to gather in order to represent the population? Now, sample size determination is closely related to statistical estimation. Quite often, we ask how large a sample is necessary to make an accurate estimate. The answer is not simple, since it depends on three things. And what are those three things? First is the maximum error of the estimate. The second is the population standard deviation. And the third one is the degrees of confidence. For example, how close to the true mean do you want to be? Whether it's 1 unit, 2 units, or 5 units or more. And how confident you wish to be, whether it is 95%, 90%, 99%, or etc. For the purpose of this discussion, we will assume that the population standard deviation of the variable is known or has been estimated from the previous study. Now, sample size determination when the population standard deviation is known. The formula for us to determine the sample size when the population standard deviation is known is this one. N, which is the population size, or the sample size rather, is equal to the squared quantity of the specific confidence level times the population standard deviation divided by E, where E is the maximum error of estimate. If necessary, round the answer up to obtain a whole number. That is, if there is any fraction or decimal portion in the answer, use the next whole number for the sample size n. So, for example, the answer would be 9.2. The final answer, or the sample size, will be 10. Now, let's take an example. A scientist wishes to estimate the average depth of the river. He wants to be 99% confident that the estimate is accurate feet. From a previous study, standard deviation of the depths measured was 4.38 feet. Now, since the scientists want to be 99% confident and then it is accurate within 2 feet, then we are going to first determine the variables needed in our formula. So for our solution, our maximum error, or the error, would be 2, since the scientist wants to be accurate within 2 feet. Next, the standard deviation of the population is 4.38 feet. That is taken from the previous study. Next, our z score would be 2.58, since the scientist wishes to have 99% confidence level. Now, where is this 2.58 came from? Remember the table that I gave you already pertaining to the normal distribution. Okay, so to get the z in this example, this is just the same in getting the z of the confidence interval when n is greater than or equal to 30, our previous discussion. Okay, so for you to refresh. Okay, so what we're going to do is that we have to subtract the 99% from 100%, which is 1%, or equivalent to 0.01. Then divide this 0.01 divided by 2, and then this number would be subtracted from 1. And then the number that you are going to get in the previous step, you will look that number in the table given to you. Okay, so the z is equal to 2.58. Now, we can now substitute these values to our formula. Okay, so taken from the previous slide, the formula of n is equal to z times the population standard deviation all over e, and the answer would be squared. Now, substitute, you have the quantity 2.5 times 4.38 all over 2. So using your calculator, you can now get the answer. Okay, so after you get the answer squared, you have to square it up. And the answer must be 31.92. And since this is 31.92, we have to round it up to the next whole number. Therefore, the answer must be 32 samples. So the scientist should have 32 samples for him or for her to be confident, 99% confident, that his or her results would be near to the population mean. Now, it's not all the time that we're going to use this standard deviation of the population. So taken from the previous examples, previous discussion, we use proportions of the mean or proportions of the population. Now, if we are going to use the proportions, then the formula will be this one. Okay. So n, sample size, is equal to the product of p hat and q hat times the quantity of z all over e squared. So again, if necessary, round up to plain a whole number. Now, let's have an example. First example, a researcher wishes to estimate with 95% confidence the proportion of people who own a home. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Now, first, we have to determine the values of the variables in our formula. Now, the E, the maximum error, is 2%. Convert the 2% to decimal. So 2% is equal to 0.02. Next, the p hat. So the p hat, those people who own a home computer, is 40%. Okay, and this 40% will be transformed to decimal, which is equal to 0.4. And then the q hat is 0.6. Okay, now the z is equal to 1.96. Okay, so since the researcher wants to have 95% confidence, then we have to look for the 95% confidence using the table of normal distribution. Now, since we have the variables the values of the variables needed for our formula, which is this one, then we can now substitute these numbers in our formula. So P hat is equal to 0.4, Q hat is equal to 0.6. Okay. So where these values came from, so let's see. Okay, so E is 0.2, substituted here, this portion, which is this portion. Okay, and then P hat is 0.4, so this is the P hat. Okay, the Q hat is 0.6, 1, and then our Z, which is equal to 1.96. Use your calculators for you to obtain the answer. Okay, so the answer must be 2304.96. Okay, which is equal to, since we have to round it up to the next whole number, the answer must be, okay, 2305. That's correct. Okay, now let's have another example. Now, the same researcher wishes to estimate the proportion of the executive who owns a car phone. Okay, she wants to be 90% confident and be accurate within 5% of true proportion. Find the minimum sample size necessary. Now, first, we have to identify the variables of our formula. Okay, so for our solution, our E is equal to 0.05 since the researcher wants to be accurate within 5%. Now, the researcher wants to be confident with the percentage of 90%. Therefore, the Z is equal to 1.65. However, if we are going to see, okay, if you notice in the problem, you could not identify the P hat or the Q hat. In this case, most of the statistician, if you don't see or you cannot identify the P hat, then most of the statistician assume to be that the P hat is 50%. Okay, and the Q hat is another 50%. So that's quite big enough for us to determine the sample size. Now, so substitute to our formula. So this would be our formula, and then substitute. So we have, okay, 0.05 the P hat and 0.05 for the Q hat, and then our Z is 1.65 all over 0.05. Okay, and then square. Therefore, using your calculator, the answer must be 272.25. Now, we have to round it up to the next whole